to, yeah, you're using lines. Go ahead, yeah, that's fine. You're using lines to, this will be a while.
All right.
Is that okay?
Yeah, it's cool.
Okay. You're using lines to project to a vanishing point. And lines, straight lines, right, infer geometry, right? So imagine what it would be like to not have any geometric forms around you, right? And that was, we existed that way for, as a species, right? When, you know, with the caves, right? No geometry per se, right? There's no math. May have a cursory understanding of math, but no geometry, no straight lines, no squares, no rectangles, no triangles, none of that stuff, right? We live in a society today that has it everywhere, right? So we deal with space in different ways than we would have back in the day when architecture didn't exist, right? So linear perspective is a way to grapple with that sense of space in a geometric way, right? So for instance, these rows of desks, they're a result of right angles, right? There's a right angle here. Two sets of parallel lines. That presents a different type of challenge than if I was out in the wild, in the woods, drawing a scene in the woods, right? Because there's no system, there's no apparent system involved, right? In the building, there's an apparent system involved. Parallel lines, right angles, triangles, whatever. So the Renaissance artists devised a system to deal with that. And in a large part, it was the architects who needed that to enable themselves to draw renderings, make renderings of structures that they conceived in their head, right, to build. So they created the linear perspective. And then the painters, you know, sculptors to a lesser degree, painters really, right? So all it is a system, it's a construct, it doesn't really exist. So it's a system that enables one to duplicate or replicate as best they can the three-dimensional world onto a two-dimensional surface, which is what we're struggling to do here. The camera kind of does it already. When you put a lens on a camera, take a picture, it's interpreting that and it's putting that image on a flat plane, the film or the sensor or whatever, okay? That's doing the job for you. But we don't have that luxury being that we're drawing from observation, so we got to deal with three-dimensional space. So one of the first rules, and this applies, by the way, to, like, you know, if you're in the wild and you have no architecture, a squirrel in a distance is going to look smaller than a squirrel up close, right?
Right.
Even though you realize that squirrel in the distance is probably the same size as one up close, right? So you're, you know, but then you stare here as well. Why that exists that way? Why is the universe built that way? I don't know. But it is. It has something to do with space, right? Probably time, too, to a certain extent. So things that are further away get smaller in our field of view, right? Relative to things that are close. It's a relative thing. By the way, perspective is just your point of view. Your perspective on life, your perspective on politics. You know, you have a personal point of view, right? That's all, and this is a visual point of view. That's all perspective is, okay? It's your point of view relative to something you're looking at. Okay? Call it perspective, right? So we have the horizon line. Make sure people can see too.
Yeah.
You can come over here. Why don't you come over here?
Okay, awesome, thank you.
Chair right over there. So let's do the proverbial railroad tracks going across the desert, right? Two parallel lines. We know they're parallel in reality. And there's the ties. Here's the sky. Here's the ground. Right? There's the horizon line. Now that horizon line, in this instance, is the divider between the sky and the ground, but that's not what it really is. what it really is your eye level relative to something. We'll talk a little bit about that, okay? In this instance, the ground and the sky are so far away, or you know, that divider, the line, the horizon, is so far away that it becomes almost even with your eye level, okay? But if you're looking up a hill, let's say you're looking up a grade, right? And then the sky and the ground are up here somewhere, that's not the horizon line. The horizon line would still be down lower. It'd be at your eye level. You're looking into the ground, kind of, okay? But for argument's sake, to begin with, you're looking out over the ocean, the water, the sky, that divider is the horizon. But you got to keep in mind your eye level is just about 5 or 6 feet above that. It's just so far away that it doesn't really matter, right? You know, everything kind of squishes down. So that where the sea and the sky meet might as well be the horizon line, your eye level. Okay, even though it's not. Because you'd have to get your head down in the water, literally, for the horizon line to meet that place where the sky and the water meet. Okay. So, but for argument's sake, these tracks would disappear at the horizon line, where in this case the desert ground and the sky meet. Okay. And they converge at what's called what? What's it called?
Focal point or something.
Yeah, a point, but what kind of point? It's not. Yeah, it's vanishing point. Yeah,
okay.
Vanishing
Yeah.
point. So focal point's more of a compositional device. Okay, can be a focal point too, but we call it the vanishing. Everything would vanish. Where two parallel lines would vanish, a sidewalk, a road, whatever. They vanish there. Okay, in infinity, that's infinity. Okay, they vanish. So it's infinity. That's the construct, right? Because they really don't vanish. They just can't see it anymore. That's all. So 1 point perspective, the ties here are always, it's 1 point perspective. It's a construct. It's artificial. You can't ever capture reality fully. So you're always fudging things. In this construct, 1 point perspective, or horizontal lines, the ties on the railroad tracks, are always parallel to the top and bottom of the page, or absolutely horizontal. You only have two choices in 1 point perspective for horizontal lines, or lines that run parallel to the ground. In 1 point scheme, okay? Not 2 point or 3 point or 5 point or whatever. We'll talk about that later. 1 point scheme. They either are straight across, horizontal, okay, or they move away from you and converge at the vanishing point. It's the only two choices in 1 point perspective, okay, for horizontal lines, all right?
So conceptually, in a 1 point perspective, you're standing in the middle of the tracks.
Here I am, that's right. But that's a really good question because that was where I was going to ask you next, or go next with this and ask you. In this scenario, it looks like I'm standing in the middle of the tracks, right? Which is dangerous. I can draw a set of rail tracks right next to it, though. It's still in 1 point scheme. Okay. These are still horizontal. And they go to they're parallel. So those are parallel tracks. This set of tracks is to my left now. I'll draw a set of tracks to the right. So imagine you're standing in a train yard, right? What's that? Have I ever been to a train yard? An infinite train yard, which I love trains and trains, so I would love that space. It's an infinite train yard. It's a great title, actually. They would all, this would be skinnier, and these would all be still absolutely horizontal because they're not moving away from me. They're parallel to my body. I'm facing it directly, and they're all going to a vanishing point right in front of me. Okay. It's like a wide highway now, right? Looks like a wide highway. I could get rid of this and those tracks Still 1 point perspective, just happened to be to my left. From here. So this is like a center axis right here. If I put a dot down here, call that in the 1 point scheme a center axis. Okay? The top, we'll do 2 point later on, so I don't want to get confused here. But so the ties aren't moving away from me; they're horizontal to my shoulder, parallel to my shoulders. The rails are moving away from me at a right angle. Right? When they built these tracks, you know, they built them in such a way that the ties and the rails are at right angles to one another, obviously. Okay. Okay. There's no weird angles here. There's no 45-degree angles, none of that. It's either something moving directly away from me or something parallel to my body. Okay, this is oversimplification of reality, but it is what we need to do in art to do the three-dimensional to the two-dimensional, make it look three-dimensional. So let's build a little cube. Using 1 point perspective, little box or cube. There's the vanishing point. This is arbitrary. I'm not looking at anything. I'm making it up in my head, right? So it's a made-up scheme that I'll show you how to apply to a real-life situation. Usually, a lot of the times you'll have, when you deal with perspective, it's like in a made-up situation. But you know, you can find out where the vanishing points would be if they did exist in any situation. It's just very difficult to do. It takes some thinking through the situation. And I'm going to show you today how to do that in a 1 point scenario. Okay. Okay. So a cube. How many sides to a box or a cube?
6.
6.
With
Yeah.
3D.
6, 4.
Yeah.
Huh?
With 3D, yes.
If it's 3D, that's right. Yeah. There's 4 sides to a square, right? Yeah. Kind of linear sides, but 6 sides, which seems weird too. It's like, why 6? It's a weird number for, yeah. But I mean, I'm talking kind of existentially. 6 is an odd number for the whole thing, right? Like 4 sounds good, right? But 6, that's weird. But there's 6 sides to a cube. Yep. Okay, or a box. So I'm going to draw a box in 1 point perspective. You've probably done this, most of you, you know. So in a 1 point scheme, the front of that box, I'll draw that first, okay, the front, which is just a square, right? And it's parallel to my body. It's a plane. So that's just a plane, right? That's a flat shape. There's no dimension to it. This line right here, the bottom of that front plane, parallel to the edge of the paper, or absolute horizontals, and its partner. The verticals are always that, just vertical. So they're always parallel to the edge of the paper. That's pretty simple. Everybody with me so far? Now let's make it into a cube. So we got to extend these 4 corners of this flat plane into infinity. Oh, it so happens I have a vanishing point up there. I can extend the cube to that vanishing point. So I have a little point here, point here, point here, point here. And what do I do with those little points? Yeah, lines that go up to the vanishing point, right? Yeah, I'll just, just literally do that, right? Remember, this is in front, though. That's where it gets complicated. This line, this is the back line point. Now, to finish that off, I could go, I could do it over here, but I always like to do the top. So all I'm going to do is draw a line across to designate the top plane right here. I haven't drawn the rest of the cube. We're going to draw a cube that's transparent here. So can you see the front plane, right? And the plane that's moving away from me. Can everybody see that plane at the top plane moving away from me? Notice these 2 edges that are parallel in reality are getting closer as they move back in space, because the back side needs to be shorter than the front side. Like the railroad tracks, the ties that are way far away from me, all the way back here, are tiny, right? till they disappear, and then they get bigger, wider and wider and wider. That's the first rule of perspective, right? So the reason these go to a vanishing point is the back edge needs to be smaller or shorter on my drawing than here. That's going to create that illusion of depth. Okay. Now to finish the square off, I did absolute vertical. Boom, 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 until it hits there. Kind of hard to do on the board. So here's the side. See how narrow that is? Look how foreshortened that side is. But the vanishing point gives me that opportunity to create that sense of reality. You know, it'd be hard for you to conceptualize the side of a cube that in that narrow and thin, you know, of a configuration, but it's there. Now, how do I finish off the cube? Yeah, I just go straight over, right? This line's not moving away from me, so it goes straight over till it hits here. Boom. And then straight up. If I did everything correct, remember this is in front, here's the bottom plane. Here's the front plane, of course. Here's the left side plane. Here's the back plane. Here's that thin side plane. Then here's the top plane. It gets a little kind of illusionistic, right? But everybody see that? Okay. Notice it's a cube or a box, right? So it's symmetrical. Notice how foreshortened this side is, and how much bigger its partner, the opposite side, is. Much wider. Here. Wider, narrower. Why is that?
Because the right side of the cube, you're almost looking straight down
Yeah.
the side because it's almost right in front of you.
Because of this vanishing point, right? Yeah, it's closer to the axis that's created by this vanishing point, right? Than this is, right? So this is going to open up. Everything that moves, everything out here is going to open up more. If I drew a cube out here, I'll put it up a little higher. Start with the front, you know, straight on. Project out to the same space, same vanishing point. You know, I see a lot more of that right side there, right? Because I moved the cube over from the vanishing point. Okay? So that axis plays a role, you know, that vertical axis. People don't like talk about that a lot in one-point perspective, but that's really important. It's delineating left from right in relation to you and the world you're looking at in one-point scheme, okay? And this is oversimplification of what really is going on in the world, but okay. Any question about that? And I could draw a cube anyway. I could, you know, draw a floating cube that's above my eye level, right? In this case, I would drop the lines down. I'll go straight over. Well, there's a cube floating in space. There's the underneath part, right? It's above my eye level. Oh, I can see up underneath it. They're all parallel to my shoulders. All of them are lined up with each other, parallel to my shoulders. There's a painful symmetry to this existence. Everything's lined up beautifully, okay? That allows me to go all to the same vanishing point. The moment the world, you know, which is really the case, the world is not that easy, right, to navigate. The moment you start kind of shifting and moving geometric forms within the space, then you multiply the vanishing points, and we'll get to that later when we do two-point perspective. I'll show you how that works, okay? But this scenario, everything is perfectly lined up in the world, okay? Everything's at right angles to one another, et cetera, et cetera. And again, the world's not that simple, but we're just learning how to navigate linear perspective here, so we're going to keep it simple for the time being. Okay, any questions about this? So this line, while in this scenario kind of is where the ground and the sky meet, it in reality it's just our eye level. And everything below that, it is below our eye level, literally, and everything above it is above our eye level, literally. And you can have things right at eye level too. So let's say there's a huge cube here, you know, that would run there. The bottom would run to there. Top would run down to there, right? They would still, you know, would still obey The lines that are moving away from me, boom, boom, would have to still go to that vanishing point. Just that they are at eye, the thing is at eye level, so they can converge in opposite directions. Okay? All right, so let's imagine that instead of looking at the cube from the outside, we're going to look at the cube from the inside. We're going to be in the box now. All right? Which is what you're going to do in the hallway. Literally, you're in a box right now. This room is a box. The hallway's a box. You know, we live in boxes. Right? Everything's based on that idea of the cube and the cylinder, the geometric forms. It kind of controls our existence. So, how many, in theory, how many, when I'm in a box, in a cube, how many planes or sides, I'll call it sides, but they're planes essentially, of that cube can I see at one time? 5, yeah. I can peripherally see this one, right? But I wouldn't draw it, right? What I would draw is that plane, right? The front one I'm looking at straight on. These two side planes, and the top bottom plane. Okay, so when you're drawing a room, that's essentially what you're drawing. You're drawing 5 sides of a 6-sided figure, or 6-sided figure shape, form. So if I were to draw this room right here, we're all kind of pretty familiar with it. It's longer. Right, the walls are kind of all the way around longer than they are high, right? Can you kind of sense that, right? And we'll figure out how to do that here shortly, but not figuring out by how much. But so I'm going to draw that wall, that shape of that wall as I kind of see it. There's a lot of junk in the way. Like I got the table and the bags and the light tables and the trash cans, and I can't see the bottom of that wall. But I know it's there, right? So I'm going to simplify this space. You're going to be doing that today when you go out in the hall. You're going to have to simplify the space in order to navigate it, okay? You're not going to be drawing doorknobs and exit signs and all those detailed things. You're going to be overly simplifying the scenario for yourself. So in this case, I'm going to draw that wall back there. So I'm kind of going to draw a shape that kind of looks like it. I know it's longer than it is high, so I'll guesstimate it, something like that. Kind of the shape of that one. Everybody see that, right? Okay. Now I'm looking at it directly, right? The moment I turn my body and look into the corner of the room, rather than facing the wall directly, it becomes a 2-point perspective drawing rather than a 1-point perspective drawing, because I'm not facing any plane directly. They're all weird angles now. Okay, we'll deal with that when we talk about 2-point perspective. I might show you a little example of it here, but for the time being, understand that this is 1-point perspective. So my body, it is perspective. That's your point of view. My body is confronting the world in a very formal, straight-on way. It's confronting that wall in the formal, straight-on way. Okay, that's really important. Everybody understand that? Okay. So it's how your body is in the world. That's the perspective. Now, I've drawn the shape of that thing. Now I need to figure out what my position is relative to that thing that I drew. So the first thing I'm going to try to figure out is where should I place the horizon line? Notice I didn't put the horizon. The horizon line is only relevant in relation to something that I'm looking at. I can't put a horizon line on this drawing until I've drawn the thing that I'm going to compare it to, right? Which is the wall, right? So I draw that first, that wall. Where would I place the horizon line here relative to my height right now?
A little high.
Huh?
About 3/4 of the way up.
Yeah, so what Ted's doing, he's doing fractions, right? Remember, fractions are important. So he's in his mind, he's seeing my eye level relative to the wall at about 3/4 the height. I would say somewhere around 3/4 to 2/3 high, right in that area. Okay, you got to start doing that. You got to start thinking in terms of fractions. You don't have, if you get to fifths, like a fifth versus, that's kind of at the limit, right? Quarters are easy to conceptualize. Quarter, that's half, right? 2/4 is a half, quarter. Thirds, a little above half, right? Halves are real easy. Halves, quarters, thirds, pretty easy to figure out. Fifths get a little tricky, okay? So I would say, yeah, 3/4 to 2/3, somewhere in there. So I strike a line. This line does not exist. It's an abstraction, right? It's conceptualization. So I strike a line from edge of page to edge of page, all the way through this at about 3/4 to 2/3. So what I've done now is denoted my eye level relative to the object I'm drawing. Okay? In this case, just that wall. Now let's put the vertical axis in. That